All right. Okay. So I've shared my screen and you guys would be able to see that in some time. Okay. All right. So let's talk about what we have been discussing in the past week. Okay. Initially, we started off with the first chapter of P1 Maths, and then we discussed the second chapter. We are still discussing the second chapter, that is functions. Now, in functions, we are done with the first unit where we just discussed the basic definition of a function. After that, we discussed composite functions, and today we are going to talk about inverse of a function. So if, let's say, if you were not able to understand the first unit or the second unit, that's completely fine because this is not related to all of that old content. Okay, yes, obviously some part of this is related to the old content as well, but there I will be explaining everything. Okay, so let's start off with the third unit, that is 2.3. All right, it's 2.3. Inverse functions. Okay, this is what we need to discuss, but before talking about inverse functions, I'm pretty sure all of you would be knowing how to find inverse of a function. We have discussed this in O levels as well, but before talking about how to find inverse of a function, we need to talk about two most important things. Okay, let's talk about two theorems or two definitions or two rules that we need to follow. Number one, the domain of f inverse of x is the range of f of x. Okay, let me explain this, then I'll talk about the second one. Okay, now it says the domain of f inverse of x is the range of f of x. For instance, just know at this point you don't know what exactly an inverse function is. You would be having a function f of x, you would be having a question that would ask you to find out the inverse of f of x or g of x or h of x, whatever the function is. I'll tell you how to find the inverse. That's very easy. The important parts would be where the examiner would ask you to find the domain or range of the inverse function. Okay, so there we will be using this property. Just know, if you have been asked to find the domain of f inverse of x, there's no point in wasting your time and first finding out f inverse of x and then finding out its domain. No. You're just supposed to find the range of the function. This would get better in a minute. Let me write down the second part of the theorem. And then the range of the inverse function is the domain of f of x. Okay, these are the two things that you need to keep in mind. Okay, so I'll tell you where exactly they would be used. Forget it for now. The second important one is an inverse function f inverse of x exists if and only if f of x is 1 to 1. That is it. Okay, these are the two important things I was talking about, and now we are in the position to solve the questions. Okay, the second one is important. Let's discuss that, and the first one would get clear once we talk about that question. Okay, the second one says an inverse function f inverse of x exists if and only if f of x is 1 to 1. Now it could be that the examiner is giving you a few functions, and the functions are not one-to-one. If the function is not one-to-one, you would not be able to find its inverse. And how exactly do we define a one-to-one function? Okay, let's talk about that. So a one-to-one function is basically this. If I talk about the graph of a one-to-one function, it's something of this type. Okay, now I know that for each value of x I have one value of y. For each value of x I have one value of y. For one value of y I have one value of x. Okay, so we have one to one. One x is going to one y. Okay, this is the difference in one to one and many to one. If I talk about many to one over here, I'll just erase this. And this is what many to one looks like. Now what's happening here? For both of these x's, we have the same y value. This y value corresponds to 2x value. So in short, many to one. 2x values are corresponding to one y value. Okay. This is my domain. This is my range. I have A, B. I have 1, 2. So this would be happening. 2x values are corresponding to one y value. This is y, this is x. Okay. Two values in domain are corresponding to one value in range. So this is basically when you have many to one. So this is basically a function that is said to be many to one, and you cannot find the inverse of this function. Okay. All right. But we will discuss a few cases and then you will understand that yes, inverse is possible. But for inverse, you will only be talking about this part of the function, right? Only this part of the function. Because if you talk about this part of the function here, for 1x, you have 1y only. Any confusions for now, please tell me quickly. Obviously, I don't expect that you guys were able to understand all of this because for now we have not discussed any question. But just the idea. Is the idea clear?
Yes.
Miss,
Okay.
for the inverse,
All.
we're going to be considering only the first quadrant.
Sorry, please say it again.
Miss, I'm saying that for inverse, we are only going to be considering the first quadrant of the
Yes,
graph.
I will definitely come back to this part. Yes, it could be this part, it could be this part, or it could be that part. If a function in general is many to one, we can pick up a specific section of that function which would not be many to one. For example, if I talk about this part of the function, so this is certainly not many to one. For one value of x, I have one value of y only because this part is not in the domain now. I am only talking about this, okay? Obviously, this would get clear with an example. Don't worry about it. Let's start off with the examples. Then we will definitely come back to this one in an example, okay? So just don't worry about it, okay? And everything is there. So I will be scrolling up again and again. Okay. All right, okay. So let me talk about the first example and then we will be talking about all of it again. Okay. Example number 1. Okay, let's talk about use by start off with with simple example. F of x is equal to, now we have a function. F of x is equal to root x plus 2 minus 7 for x belonging to the set of real numbers and x is greater than equal to. Let me write it down there directly. Okay, this is the function and the domain is that x belongs to the set of real numbers and x is greater than equal to minus 2. All right, so this is the very first example. Let's talk about the example first. It says the function is f and it's equal to root x plus 2 minus 7. And what is this? This is basically the domain of the function, and it says x belongs to the set of real numbers. It means the entire number line, okay? And then x is greater than equal to -2. So the first part said entire number line, and the second part says all the real numbers which are greater than -2. So this is going to be the domain, okay? This is basically the domain according to the x-axis or the number line. All right, okay. What is the question saying now? Find an expression for f inverse of x. Okay, part A of the question is, let's keep it simple. Find f inverse of x. Okay, this is the first part of the question, and I have seen students have their own methods of, finding out the inverse function. That's completely acceptable. But still, for the sake of completeness, I will be talking about a few fixed steps that we can follow, and you can follow these steps, okay? Every time you have been asked to find the inverse function. So, step number one, we have f of x equals to root x plus 2 minus 7. Step one says, write f of x as y. So we can write it down as y equals root x plus 2 minus 7. This is the first step, okay? All right. The second step says, it's step 2. It says interchange x and y. So this is the equation. Now I need to interchange x and y. This would become x and this would become y. So it is x equals root y plus 2 minus 7. I have interchanged x and y. And last step or the third step is rearrange to make y the subject. Okay. All right. So this is the last step. Okay. Now again, this was the final equation. I'll write it down again. It's x equals root y plus 2 minus 7. Now I need to make y the subject. So first of all, I will take this minus 7 on this side, and it would become x plus 7 equals root y plus 2. Then I can take square on both sides. So when I'll take square on the right side, square and square root would be cancelled, and I would be left with x plus 7 squared minus 2 equals y, and I can write it as y equals x plus 7 whole squared minus 2. Okay, so let me just repeat. If you were not able to understand whatever we have discussed in the beginning, like these two rules, it's completely fine. We will be talking about these examples, and then again, I will refer to them and things would make sense. Forget about these two rules, okay? Just focus on this example number one. In example number one, we have just started off with the basic concept that we discussed in O levels as well. You have a function, it's root x plus 2 minus 7, and the domain is given. The domain is given, and the domain says, I'm just talking about the domain again and again, just so we get good with the domains and range as well. Okay. Domain says x belongs to the set of real numbers. It means x has every number in maths, that is all the positive numbers, negative numbers, 0. And then after comma, it says x is greater than equal to -2. So the interpretation would be x is greater than equal to -2, and it is belonging to the set of real numbers. So you can say every number that is greater than equal to -2. So it would be -2, -1, -1 by 2, 0, 1, 2, 3, 100, 1 billion. Every number greater than -2, and it could be equal to -2 as well. Okay. This was just an interpretation about the domain, but the main part was finding f inverse of x. Okay. So we have three steps. Just use these three steps and you would be able to find the inverse function easily. Step one says If you have f of x, it could be that you have g of x, h of x, whatever the name of function is, just replace that with y. So we had f of x here and I've written y here. Okay. Then we need to interchange x and y. So we have interchanged x and y. We had y here and x here. So I've just interchanged x with y and y with x. Yeah, yeah. Over here I've written x and here I've written y. Okay. After that, the third step says rearrange to make y the subject. Now I need to make y the subject. So all of us know how to make any variable the subject by taking everything on the other side, and I took -7 to the other side, it became +7. I squared both sides, and finally I got this. Yes. Any confusions with finding out the inverse of f of x? Please tell me honestly.
No, ma'am. Miss, but at
All
the
right.
end, we will
Okay.
get the F inverse of X.
Please say it again. I was not able to understand what you were saying.
Miss, I'm saying that in the last step, where are we going to
Hmm.
write the F inverse of X?
Okay. Yes, that is correct. 1 second only. Here it is. Okay. All right. So once you have y equals x plus 7 squared minus 2, like once you have made y the subject, in the end, you can write it down as f inverse of x equals x plus 7 squared minus 2. Obviously, yes, we had y over here, and the main question was about finding f inverse of x. So this would be the last step, and that's important. Obviously, we need to write down f inverse of x instead of y. Okay.
Okay, Miss.
All right. Okay. And then the next part of the question says solve the equation. Now you need to solve an equation that is f inverse of x is equal to f of 62. Now we already got an expression for f inverse of x. Okay, let me write down both the functions again. F of x is root x plus 2 minus 7, and we have just calculated f inverse of x. That turned out to be x plus 7 squared minus 2. Okay, now this is the equation that we need to solve. This is the condition. So we have f inverse of x and we have f of 62. Let's just find out the value of f of 62. F of 62 would be root 62 plus 2 minus 7. So it would be 1, right? It would be 1. This would basically be, let me write down properly. This would be 8 minus 7, and that would give you 1. So f of 62 is 1, and f inverse is what we have just calculated in the previous part. So let me just write it down. The condition is f inverse of x is equal to f of 62. F inverse of x would basically be x plus 7 squared minus 2 equals 1. And now I can take this minus 2 on the other side. So this would give you x plus 7 whole squared equals 3. Now I can take under root, and this would give me x plus 7 equals plus minus root 3. And finally, the answer is going to be x equals plus minus root 3 minus 7. And we can write it this way. X is equal to minus 7 plus root 3, and then x is equal to minus 7 and minus root 3. So for the second part of the question, this condition was given and we had to use this condition. So in order to use this condition, first of all, We need to find the value of f of 62. F of 62 was basically 1, and f inverse of x was calculated in the previous part. This was f inverse of x, and after equating both these, we simplified and we got two values of x. Number one was minus 7 plus root 3, and the other one was minus 7 minus root 3. Yes, any confusions over here? Anything that you were not able to understand?
Ma'am,
Yes.
when writing the answer, wouldn't we further
Hmm.
solve it and write one value for x?
So like you're saying minus 7 plus root 3, the calculated value of this thing by plugging in the
Yes.
values and writing down the decimal? No, that's not needed. Whether it would depend upon the examiner. Like if he's saying give your final answer correct to three significant figures, then obviously it makes sense. You will be using your calculators and giving the answer up to three significant figures. Okay. If the question says give the exact answer, so for exact answers fractions are going to be fractions, and surds, like this is a surd, so surds are going to come as it is for exact answer. This time around nothing was mentioned in the question. It only said solve the equation, that is it. So this answer is completely fine. But if he is specifying something, and then we have some rules in general that whenever you are solving something, for example, if you talk about the coordinate geometry, there you will come across too many decimal numbers. So obviously there I will talk about a specific rule through which we would be knowing that even if the examiner is not mentioning, you need to write down the answer up to three significant figures. But for these type of questions, when the examiner is not mentioning, you can leave the answer this way, you can leave the answer as a fraction, they are completely acceptable. There's no issue in this. Okay.
Okay.
All right. Okay. So this was the first question. Let's talk about the second one. That's where we will be using the properties. Okay, let me just write down the question. It's question number 2. It says f of x is equal to 5 minus x minus 2 squared for, let me write it down this way. And then the domain is given, and the domain is that x belongs to the set of real numbers and x is greater than equal to k and it's less than equal to 6. Okay, this is the function. Part A says state the smallest value of k for which f has an inverse. All right, okay. So this is the question. Now I'll explain the question and then we will discuss, okay? F of x is 5 minus x minus 2 whole squared. Then we have the domain, and the domain says every number that is between k and 6. You know, when I say every number, I mean when we talk about integers, we only have the whole numbers, right? But when I say every number, let's say I say every number between 1 and 2. Now, some students would say that we do not have any number between 1 and 2, but trust me, we have infinite many numbers between 1 and 2. We have 1.0000001, we have 1.0001, we have 1.002, we have 1.12, we have 1.13, and so on. We have infinite many numbers between two numbers. Okay. So when your x is a real number, or when x belongs to the set of real numbers, it means the entire number line. And then this is basically going to specify the two numbers or the exact interval of x. Okay, so this was just an explanation about the domain. But the question says, state the smallest value of k for which f has an inverse. Okay, let's scroll up and see where exactly we have discussed this. Okay, here it is. An inverse function f inverse of x exists. So this means that inverse of any function exists if and only if f of x is 1 to 1. Okay, now we know what exactly 1 to 1 means. 1 to 1 means for 1x we need 1y, even if the total function or even if the function in general is not 1 to 1. For example, we discussed the quadratic curve that was not 1 to 1, that was many to 1, but after restricting some part of it, we were able to see that yes, some part of the function was 1 to 1. Okay, so this is the idea. Here you need to solve it this way. An inverse function exists if f of x is 1 to 1. So this is the only thing you need to know. They want you to find the smallest value of k for which the inverse exists, or for which f has an inverse. It means that this is a quadratic function. So in general, this is not 1 to 1, this is many to 1, but we will be making the graph and then we will discuss that for what value of k exactly it is going to be. It is going to have an inverse function. Okay, so let's talk about the graph. All right, okay, 1 second only. Okay, so let's see how to make this graph as well. That's also important. All right, the function is 5 minus x minus 2 whole squared. Okay, this is the function. This is x, this is y. So we have a few aspects while plotting the quadratic curve. This is negative. It means we would be having negative x squared. So the shape of the graph would be something of this type. Okay, but we need some more things as well, not only this part. We need to understand that the turning point would basically be at the negative version of this number. It's 2, and then this comes as it is, it's 5. So the turning point would be at 2 5. Let's say this is 2, for instance this is 5. This would be the turning point, and then I'm just going to make the graph, a rough sketch of it. Okay, because the question was not to make the graph or sketch the graph. The question is just to find the smallest value of k for which f has an inverse. Okay, and then one last thing, this is my domain. So let's just see what is the value of function at x equals 6. So for that, I can just do it this way. F of 6 would basically be 5 minus 6 minus 2 whole squared, and it would give me 5 minus 16, and that is going to be minus 11. So for example, this is x at this point, it would be minus 11. Okay, that is it, just a rough sketch to understand something. So students, the question was to find the smallest value of k, this is k, such that the function has an inverse. If I look at the function for now, I can clearly see it is many to 1. Why is it many to 1? Because two values of x are corresponding to one value of y. Okay, that is why it is many to 1. Okay, fair enough. And let's say if you are not able to understand the many to 1 concept this way or the 1 to 1 concept this way, just understand this small test I'll be explaining in now. Okay, just make a horizontal line. Let's say you need to identify if a function is many to 1 or if it's 1 to 1. Just make a horizontal line on any part of the graph. If that horizontal line is cutting your graph at 2 points, it would mean that your function is many to one. Okay, many to one. Yes. Again, it's many to one. Okay, so you can make the line anywhere you feel like. Obviously, if let's say if this was something of this type, for example, okay, for example, now you can't say that when we will make the horizontal line here, it would not be cutting the graph at 2 points. No, the idea is that you can make multiple horizontal lines, and if any horizontal line is cutting the graph at 2 points, it would mean that your function is not one to one, it is many to one. Okay, so if you're not able to understand the concept of many to one directly, just understand the horizontal line test. Now similarly, I'm just explaining this quickly. If I had another graph, let's say I had a straight line. Now when I will make horizontal line over here, anywhere, the line would just cut the graph at 1 point only. So this is one to one. So if your horizontal line is cutting the graph at 1 point only, it's one to one. If it's cutting at 2 points, it's many to one. Okay, so now through horizontal line test or through the idea this way or the other, you know that this function on its own is certainly many to one. And in order to have inverse of a function, you want it to be a one to one function. So you need the smallest value of k for which this would be a one to one function. So that is basically going to be this part of the graph. Okay, if I talk about this part of the graph and if I erase the other part. Now, if I will erase this, all of it. Okay, yes, that's good. All right. So now you can clearly see that now my horizontal lines are cutting the graph at 1 point only, right? On one horizontal line, it's intersecting my graph at 1 point only. So this clearly means that for 5 and 6, sorry, this is 2. For 2 and 6, as in for this interval of x or for this domain, my function is going to be one to one. Now I can say that the inverse would exist. But if I talk about this part, or if I talk about the entire graph or the entire sketch, I can clearly see that it's many to one. In order to have the inverse, it must be one to one. Okay. So this is the idea. So now I know that for k equals 5, this is going to have an inverse. So it would be k is equal to 2. Acha, another thing is this. Now you can say that if k is 3, let's say, or if k is 4, even then the function would be one to one. So even then the inverse would exist, but the wordings of the examiner were smallest value. So we need to look for the smallest value, and that is 2. If I talk about 1, it would be something of this type. And now if I will make the line here, it's clearly cutting the graph at 2 points. So this would not work. Okay. So in general, just know whenever you will have a quadratic curve or a parabola, and if you come across a question of this type, just look for the minimum or the maximum or the vertex basically. And then you would be able to understand the question very, very easily. Yes, any confusions over here? Any doubts? Please tell me if you were able to understand this or not.
Miss,
Yes.
Miss, you said that we can draw any horizontal line on the graph. So, Miss, what if we draw the horizontal
Hmm.
line on the vertical? Would that mean that the
Oh,
graph is 2 to 1?
sorry, please say it again. What if you make the horizontal line exactly where?
On the vertex, which is 2 and 5.
Horizontal line over here. Over here, right?
Yes,
Yes,
ma'am.
exactly. Even this would cut the graph, very good point. Even this would cut the graph at 1 point only. And then I told you, let's say if the graph was something of this type, and if you make the line here, Even here it's cutting the graph at one point only. So this was what I just said. You need to be, mature enough to see that if any horizontal line, like you can make horizontal line anywhere. Now you need to think about it, that where exactly it has to be made. You would be able to see by looking at the graph directly that if you will make the line here, it would be cutting at one point only. It would be cutting at one point only. But if you make it here, here, everywhere other than the 2 points we have discussed, it would be cutting the graph at 2 points only. And if any horizontal line, like if you're making 10 horizontal lines, out of those 10 horizontal lines, even if one line is cutting the graph at 2 points, the function would be many to one in general. Okay.
Okay, miss. So miss, like ignore the horizontal line on the vertex.
Yes, you need to make the horizontal line carefully. For example, let me give you another example. Just 1 second. Now, obviously, at this point, we just know about quadratic functions. But once we will discuss cubic functions, I'll just make a rough sketch of them. Okay. The graph of a cubic function can be something of this type. Okay. Now, if I have been asked to make a line, let me just extend this over here like this. So if I make the line here, I can't say that the horizontal line is cutting the graph at one point only, so it means it's one to one. No, I need to see that if I make the line here, it would be cutting at 3 points. So this clearly is a many to one function. I need to make a line such that I get multiple intersections if possible. If I had a straight line directly, that's very obvious. I can make the line here, I can make the line here, everywhere it would be intersecting at one point only. But by the appearance of the graph, I would understand that if I make the horizontal line somewhere in between, I would get multiple points of intersection. Okay. So that is what matters. Even if you're getting one horizontal line of that type, it would mean that your graph is a many to one function.
Okay, miss.
Yes. Is the idea clear?
Yes, miss.
All right. Okay. And what about you, Emmet?
It's clear.
Okay. All right. So this was the first part of the question. And okay, we will discuss the second part tomorrow. The second part was basically this, that for this value of k, like once we had our k that turned out to be 2, state the domain and range of the inverse function. Okay. So now uh, they wanted you to state the domain and range of the inverse function. But again, for that, we will be using the theorem. So we'll talk about it tomorrow. For this class, so far, you know that inverse of any function exists if that function is one to one. Now, it could be that the function in general or initially is not one to one. It could be that a function is many to one, but you can just pick up some part of the function that is going to be many to one. And for that very part of the function, you can say that the inverse would exist. Okay. Then we discussed how exactly we will forget about this one. We will be using it tomorrow again. Okay. All right. Then we discussed how to find inverse of a function. That was simple by writing down y instead of f of x, then by interchanging x and y, and then by making y the subject. And at the end, we had to write down f inverse of x and then whatever we got for y. Then we had a condition that f inverse was equal to this. So f inverse was clear. F of 62 turned out to be 1, and we just simplified and we got these two values of x, and we would write them down directly until and unless the examiner wants you to give the answer in decimals or significant figures or stuff like that. Okay. And then here we basically discussed that originally or initially the function was many to one. So if it is many to one, the inverse cannot exist. Another way of seeing if it is many to one or one to one was basically the horizontal line test that says you can make a horizontal line on any part of the graph, and if your line cuts the graph at 2 points or at more than 1 point, it would mean it's many to one. Now, the horizontal line has to be made cleverly. Okay, you need to make the lines, because by the appearance of the graph you would easily be able to see. If you will make the horizontal line on the top, yes, it is cutting at one point, but if you will make it in the center, it would be cutting at 2 points. Okay, so then you would know if it is many to one and one to one. Now you know it's many to one, so then verse would not exist, and you need to specify the domain. Okay, so then you could see that we just discussed the vertex, and from vertex to another point we just restricted the domain, and we got that as a function whose inverse would exist. Okay, any confusions, anything that you were not able to understand, please tell me.
No, miss.
No, ma'am.
All right, okay, so I hope this was clear then.